Now, when you round a number, you lose some information, because essentially, if I tell you that my answer is 700 and I've rounded the answer to the nearest 100, well, what was the original answer? Well, it could have been 682. It could have been 705. It could have been 743. It could have been any number of values between or within a certain error interval. Okay? And our job in this video is to really define what would the error interval be. What could the possible answers have been? And then it has been rounded to the nearest 100. Okay? So that's really the idea here. So what's the error interval? Well, what would be the smallest number that could have been rounded to 700 to the nearest 100? Okay, so, well, that would be 650, right? So 650, that is the hundreds column. To the right is a number 5, which means I would round up. So this would round to 700 to the nearest 100. And it's the smallest number I can get that would round up to 700 to the nearest 100. Because if it was 649, then my second digit here would be 4, and so I would round this down to 600. In fact, if it was this, that second digit is still 4, I would still round this down to 600. So 650 is the smallest number that would round up to the nearest 100, to 700. Now, the way that we write our answer is as an inequality. So essentially, I'm going to have my smallest number here, and I'm going to have my largest number here, and in the middle, this is what I write. Okay, so I'm going to write that x, the number, the original answer, is greater than or equal to 650. So reading it from the middle outwards, x is greater than or equal to 650. Okay, well, yeah, you can read it 650 is less than or equal to x, but it usually makes more sense if you think x is greater than or equal to 650. But there is going to be some upper value as well, right? So at what point do I stop? Is it 749.99? For example, is that the largest it could be? Well, not quite, because it could be that. That's larger. In fact, that's larger also. This is larger still. Okay? And I could keep on adding 9s onto this, making the number larger and larger and larger and larger. So I can't actually write down the number that is largest. Okay, I can't actually write down the largest number that would force me to round down to 700. So because I can't do this, I can't just keep on adding 9s because there's no end in sight. Okay, I'm going to have to keep on going and going past the board. So rather than doing that, what we do is we write down the value that it has to be less than. It has to be less than 750, because 750 will round up to 800. So x is greater than or equal to 650, but it is strictly less than 750. And this is the error interval. So the answer to the problem, whatever it was, had to be greater than or equal to 650, but less than 750. Okay? So let's take a look at our second example. 8.8 has been rounded to 1 decimal place. So what is the smallest it could have been that would have rounded to 8.8? So that would have to be 8.75, wouldn't it? Because here is the first decimal place, and the number to the right is 5 or more, which means it rounds up to 8.8 to 1 decimal place. If it was 8.74999999, okay, the next digit is 4, which means I would round down to 8.7. So 8.75 is the first value that would round up to 8.8. So you can see it's going to be in this format where we're going to have a less than or equal to symbol and then a less than symbol. Okay, they're always going to be of that same structure, always the same direction with the arrows. Okay, so what value should go here? Well, it's got to be 8.85, hasn't it? Because if we were saying, right, what about 8.499999? Again, if I put it has to be less than or equal to that, well, I could keep on adding 9s onto this. And I'm making a larger and larger and larger number, but I can't write down what the largest number is. I can just keep on adding 9s. And I'm making the number larger, but I can't actually write down the largest number. So we go 8.85. Now, can you see that in this case, we were going right to the nearest 100, and so the answer is 50 either side of the 700. Here, we're rounding to 1 decimal place, so we need to be 0.05 either side of the 8.8. So for this one, 3,250 has been rounded to 3 significant figures. Well, there's the third significant figure, and then we've got the number to the right. Okay, so that means it has to be 5 either side, doesn't it? So 3, 2, 4, 5 is less than or equal to x. That's the lowest number that would round to 3 significant figures. To get that is less than, well, add 5 onto that, 3,255. X has to be less than that value, otherwise it will round up to 3,260, which is what I don't want. So this is how we find an error interval. And you can do this for any number of decimal places, any number of significant figures, any of rounding to the nearest whole number, nearest 10, nearest 100, nearest 1,000, etc.